when they already introduced the concept of bucket up, and to handle the upcoming impact, bucket up only might not enough. We need to bucket up the right one as well. So I would like to call for the right bucket. When they already introduced you this house with the beautiful views of river, it's just a pressure to be there, right? But in the same time, our life is in danger of flooding due to climate change. As you know, the river is rising and the storm is getting stronger. So let's pick up from what Wendy left off in the previous presentation. Picture yourself living in this house, and now it's raining. You can hear it hitting your roof, and then you glance up at the ceiling. Oh no, the roof is leaking. So what do you do? What do you do? So the roof is leaking, like water is falling in. Bucket up. Yeah, you have to bucket up. And yeah, hurry up. Yeah, you have to find a bucket. Hurry up, water is falling in. Oh, thank goodness, you finally find these 3 buckets. But which one is the best? This one is too small, that one is too heavy to carry, and another one is too old to hold water. Plus, you don't know how long it will rain, or whether it will rain even harder. Now you start to figure out, right? Because you don't know what to do. Let's calm down and think it through. 1 bucket might not be enough. You probably need many over time as the rain continues. But which one should you get first or later? I think now you need a plan. Do you think so? Have you heard of the saying that it is necessary to put the right person in the right job at the right time to accomplish an important mission? Well, in this case, we need to ensure that we put the right bucket in the right place at the right time to prevent our lovely house from being flooded. On a much bigger scale, low-lying coastal cities, including Christchurch, are prone to flooding. This is because of our flood defense structure are under the pressure, so it could fail any time, like our house with the leaky roof. Like me, you may experience the failure of flood defense system before. To be honest, I experienced the big scale of the failure twice in my lifetime, which is not that long though. Do I look that old? No. I first experienced them in 2011 in Thailand, my first home. The consequence of leak turned an aircraft into a cruise ship just in one night. Fast forward to early this year, it's happened again, but this time in New Zealand. As you know, Auckland experienced severe flood ever. On that day, I was waiting for my plane. Apparently, just in one hour, I have to wait for a boat to rescue me. Clearly, our flood management system are inadequate to handle extreme storm, even now. Never mind in the future under climate change, when the full impact comes to pass. So we need a new plan to reduce the risk. But fortunately, in the city, we have plenty of buckets buried underground. We can harvest these unused buckets to collect water that our primary drainage system are unable to hold by implementing green stormwater infrastructure. I will call GSI for short. Like those 3 buckets we found in the house. These underground buckets have a different characteristic that make them less or more capable of collecting the excess water. 3 key characteristics of land that are responsible for high flood mitigation capabilities are large potential area that we can implement GSI, a large drainage area from which to collect runoff, and a significant depth from the ground surface to the high water table. Knowing these characteristics of different potential areas is a key to develop a strategic plan for using these potential area incrementally as needed in response to increased climate change impact over time. To come up with a plan, we need a tool, a methodology that helps us to understand the characteristics of land in the city. So we can identify the best location to place bucket or install green stormwater infrastructure to achieve the greatest reduction in catchment runoff volume under different climate change scenarios. Knowing this also allows us to identify how to implement this facility in a way that takes full advantage of land capabilities, and to know when to install this facility in the most cost-effective way, should it be now or later. Currently, there are 3 methodology types available. One is hydrology-based analysis. This one is good at determining how many buckets or GSI area are needed to collect the excess water, and when they are needed as climate change impact increase. But it doesn't tell us where is the best location to place bucket. Meanwhile, geographic information system-based analysis can identify the best location for GSI, but it cannot quantify the amount of stormwater that can be intercepted in particular area, so it cannot indicate how many areas are needed or when they are needed. Lastly, multiple criteria analysis can help figure out how to implement this facility to the greatest cost effectiveness. But again, it doesn't help us to determine where and when. So there is no perfect tools available. So we have to combine the strength of all these 3 methodology types into these 2 boxes, which is called HLCA+C. Methodology stands for hydrology-based land capability assessment and classification. I think now you start to feel like, holy moly, it must be so complicated. Oh, well, it is a little bit, but it's like an iPhone, you know, complex engineering, yet easy to use. Let me share the secret with you, as I think you are really lovely audience I ever had, actually. Yeah. These 2 boxes contain 4 steps. First step is to group different property located in the same drainage area into a zone. This zone is your unit of analysis. All areas within the zone have a similar potential for flood mitigation. All right. Next step is to determine how much water can be collected within your zone. The size of potential area within the zones and the depth of water table defines zone storage capacity. But the water that can be collected is depending on runoff volume that flowing into your zone. Once it hits the full capacity, the runoff will discharge from your zone. Then the next step, depending on how much water can be collected within your zone, you then evaluate the extent to which it can mitigate climate change impact under different scenarios. The more your zone can collect water, the more and the longer it can offset climate change impact. So what's next? At this point, you already know the characteristic of individual zone and their capabilities. That sounds perfect, right? But you may wonder, how do we come up with a plan from these numbers, tables, graphs, and maps? You probably start to figure out again, too much information, can't digest, right? But hang on, the last step is our secret sauce, the real clincher to develop a plan. So listen carefully. The secret is the power of classification. The classification is a powerful tool for landscape planning since 1940s, when land capability classification was first developed to group the complexity of soil characteristics into different classes. This helped planners to understand land potential and limitation to make a informed land use decisions, such as crop selection. We can do the same thing here for the classification of flood mitigation capabilities. It's translate the technical information that we have got from the previous step into a plain language that's easier to digest and to identify where is the best location for GSI, how best to implement it, and when is appropriate time to implement relative to the increased climate change impact. Let me tell you how to use it to develop an adaptation plan with climate change. The system classifies zones into six different classes. These tell us where has a higher capability than other places to offset a certain level of climate change impact. Here is an example of mapping zone capability in the Christchurch catchment. Zone shaded green classified as class 2, it can mitigate impact of moderate climate change scenario up to the end of this century. Zone with yellow, classified as class 5, have more limited capability than the green one. But in fact, if we can decide 2 or 3 of these yellow zones to work together, it can mitigate flooding impact associated with the minor climate change scenario. Under each class, there are 3 subclasses indicate the characteristic that limit zone capability. These characteristics identify what level of effort we will need to implement green stormwater infrastructure in particular zone. Knowing this helps us to make a decision about how and when to implement it cost effectively. Let's get back to the map of Christchurch catchment. Zone of subclass D, depicted by the diagonal hat there, are the easiest to implement. This because of it requires just small portion of potential GSI area to achieve the maximum flood mitigation capability. So it is a low-hanging fruit that green GSI on this land can be implemented first to provide flood mitigation in the near term. But when it's come to implement GSI on area with subclass A, the zone with cross-hatch patterns, the more effort will be needed. Land use within this zone need to be reconfigured to ensure that there is enough suitable area for GSI to achieve maximum capacity. Therefore, this might not be an attractive option for planners, as it will take them some time to convince landowners to make substantial changes on their land. However, when the flooding ramps up as predicted, sometime in the middle of this century, these options will start to look more attractive. Lastly, zones subclassified at W, the dotted area on this map, have got high groundwater level, which means their storage capacity gonna keep shrinking as the water table creeps higher and higher as sea level rise. In fact, some of them might be underwater soon. So the landowner of this area would eventually sell their land to the city and move elsewhere. So that would be a chance for city to implement or replace this area with wetland to provide flood mitigation in the longer terms. These are likely to occur in the far future. If we cannot stop the global temperature increase, a retreat will be the only option left for this area. To protect our lovely house from flooding, we shall need many buckets and a plan. A plan that tells us which bucket should we use first or later. Having a tool that integrates hydrological and spatial analysis together and harness power of classification can help planner and other stakeholders make a critical decision and come up with a plan. We have successfully applied this tool to develop an effective plan for the Heathcote catchment. If you want to know more, you can have a look at our paper here. To avoid flooding, it's just a matter of putting the right bucket in the right place at the right time. Thank you.